Hello everyone. So we have a good question from the chapter of functions. Uh, so we have a function which has been given this very big function with a limit over here in the right hand side, and on the left hand side we have 2 divided by n c alpha, right? Uh, and we have to find the least value of n plus alpha. Okay. So the first thing which we should try to do is simplify this function on the right hand side. Okay. So let me write this as fx. This is equal to limit x tends to 0 e to the power log x divided by minus 1 by 3. Why do I write this as minus 1 by 3? Well, because this particular term log 1 by e to the power 1 by 3, it's equal to minus 1 by 3. Okay, I'm not showing how because that is just too elementary. Okay, so and this is, we have an integral 0 to x 4t square natural log of 1 plus t divided by t to the power 4 plus 4. And as you can see over here, we have got a GP series till infinity, the result of which is 2, and then it has been raised to the power of x. Okay, so this is 2 to the power x divided by sine t dt. This is the integral that we have, and we have to simplify all of this, or rather we have to find the value of this entire expression. Okay, uh, so well, this minus 1 by 3, let me write this as minus 3 log x. Okay, and minus 3 log x we can write as x to the power minus 3, right? These are just properties of log, and exp, or rather e to the power log x to the power minus 3 will become x to the power minus 3. Okay, this entire thing will become x to the power minus 3, so x cube. Again, you can see that inside this integral we have got this 2 to the power x term over here. 2 to the power x does not depend on t by any means, right? So we can again bring this term out because it's not really relevant for this particular integration. Okay, so this is what we have right now. Now you can see we have got a limit x tends to 0. Okay, when we put 0 over here, we get a 0 in the denominator. Again, when we put a 0 over here, or for this in this integral, we get 0 as well. So we are having a 0 by 0 form, which means that we can apply L'Hopital rule, and I'm going to do exactly that. So let's begin. This will be, okay, I forgot to write limit x tends to 0. Limit x tends to 0. This will be equal to 2 to the power x divided by 3x square. Okay, just a second. The denominator will be 3x square, right? And okay, let me do one thing in the previous step. Let me just take this 2 to the power x outside. Okay, why? Because not outside, rather we can write it like this, right? That this is multiplied by limit x tends to 0 2 to the power x, which will basically be 1. Okay, it will not affect the value of this integration in any way, so I'll just remove this so that I don't have to differentiate that 2 to the power x again. And in the numerator, therefore, we will have 4x square natural log of 1 plus x, and over here we will have x to the power 4 plus 4 sine x. Okay, now we will put the properties of limits, that is limit, say, x to the power 0 4x square. See, the value of ln 1 plus x, sorry, the value of ln 1 plus x, limit x tends to 0, limit, sorry, natural log of 1 plus x divided by x is equal to 1. Okay. So I'm going to apply that property over here. This will be ln 1 plus x divided by x multiplied by x. This thing will be equal to 1, right? Again, in the numerator, limit x tends to 0, sin x by x will also tend to 1, right? Sin x by x, sin x by x multiplied by x. Okay, this will also tend to 1. Okay, now we can cancel the remaining terms. We can cancel the x over here, x square over here. And so the value which we have left is 4 multiplied by 4 into 3, which is 1 by 3, right? And 1 by 3 is equal to 2 divided by NC alpha. So the value of NC alpha is equal to 6. So what can be the possible values of N and alpha in this particular case? This can be 6 and 1, and this can be 4 and 2. Okay. Now N plus alpha for this one will be equal to 7. For this one will be equal to 6. Okay. So yeah, we have our answer. The minimum value of N plus alpha will be equal to 6. The answer is 6. Okay. Thank you.